Yeah. Yeah, good afternoon all. So before I start, can anyone please confirm whether my voice is clear?
Yeah.
Yeah, fine, thank you. So as part of myself, I'm Vijay. Like I hold like 15 plus years of experience. Like I hold experience in Hadoop and Spark environment. So as part of today's demo, I'm going to cover the following topics. What is Apache Spark? Why PySpark? Need for PySpark and PySpark Python versus Scala, right? Which is the better, right? Python and Scala, and PySpark features, real-time usage of PySpark and PySpark job market, right? Yes. So evolution of Apache Spark. So evolution of Apache Spark, right? It was developed, Spark was developed by Miss Zaharia, Mete Zaharia in AMP lab in the year 2009, Berkeley 2009, right? Yes. It was, Spark was open sourced in the year 2010 and it was donated to Apache Software Foundation in the year 2013, introduced in 2009 and open sourced in 2010 and donated to Apache Software Foundation 2013. What is Apache Spark? Yes, Spark is a distributed execution framework. It's a distributed execution framework in parallel process style with in-memory computation. This feature, right? This in-memory computation used for large-scale data processing, right? So in Hadoop, you see all these features except this in-memory computation, right? So here, distributed execution, parallel process, in-memory computation, and used for large-scale data processing. Okay, in-memory computation means like storage within the memory and processing within the memory, both happening within the memory level. In-memory computation, we say, right? Yes. So Apache Spark is an open source, I can say, distributed cluster computing framework introduced by Apache Software Foundation, right? So it's used for data analysis, processing, and computation. It is a general engine. I can say Apache Spark is a general engine for big data analysis, right? Yes. And why PySpark? PySpark is a Python API to use Spark. It's a Python API to use Spark. I said it's a Spark is an open source cluster computing system used for big data solution. So I can say PySpark is a lightning fast technology that is designed for fast computation, right? So PySpark is a demanding tool, I can say, among all the data engineers. So it's a demanding tool among the data engineers to work with bigger data set. So PySpark used for distributed SQL. It is used for distributed SQL, creating data pipelines, ingesting data into databases, ML algorithms, and graph and stream algorithms. Data streams, right? Graphs and data streams. Okay, need for PySpark. Need for PySpark means for performing different types of operations and huge data sets. See, need for PySpark means if you see a large amount of data is generating, right, through offline or through online, right? This data contains some hidden patterns, unknown corrections, some market trends, right, and some customer preferences and other useful information, right? It is necessary to extract the valuable information from the raw data, right? We require some more efficient tool to perform different types of operations on the big data. So there are many various tools to perform these multiple tasks. We have already got other tools available to perform multiple tasks on this huge data set. But these tools are not so appealing. So we require some scalable and flexible tools. We require some more scalable and flexible tools to crack this big data and gain benefit from it. So PySpark is such a kind, right? So we combine, so combination of Python and Spark. So we combine both Python and Spark is the more efficient way for the world of big data. That's why Apache Spark community came up with a tool called PySpark, that is Python API for Spark. Okay. PySpark, Spark plus Python. Spark can be coded with Scala, Python, Java, and our language. I don't say like Spark can be coded with only with Python. We have got multi-language support using Scala. By default, built in Scala. Which one? Spark by default built using Scala, and we can also go with Python. We can go with Java and our language, right? Yes. So these 4 languages can be used. Right, Spark can be coded with Scala, Python, Java, and our language. So which is that Python and Scala, right? Python and Scala. So Python is a dynamic typed. Scala is static typed. Means here we no need to define the variables, data types, right? If you are defining x equal to 10 based upon what value you are assigning. If you are assigning an integer value, then the integer x is an integer variable gets created. If you're assigning a float value, y is a float variable getting created. If you're assigning z as a list is created. So depending upon what value you are assigning, depending upon that, the variable gets created. So that's why we say it as dynamic type. So even we have got a function called type. Type of x is integer. Why it is integer? Because you have assigned an integer value. Type of phi, to know the type of phi is float. Why it is float? Means you assigned a float value. Scala is static typed. We use val and var here. Python is open source and has a larger community, right? But Scala has a small community as compared with Python. Python has powerful libraries for machine learning and graph algorithms. Python has powerful libraries for machine learning and graph algorithms. And Scala less as compared with Python. If you see Scala is the native language of Spark. Scala is used only for Spark environment. Used only for Spark. But Python has got 89,300 inbuilt modules for various domains, right? Not specific to a particular environment. Python has got a lot of use cases, many built-in applications. We have got many applications. Inbuilt modules are available. So for networking, for testing, for data science, for big data, for gaming, for embedded applications, for networking applications, in this way, wide varieties of applications for Python. Okay. If you see the main features of PySpark, lazy evolution, we say. In PySpark, we got a feature called lazy evolution. Lazy evolution means active evolution and lazy evolution. When defined, immediately executing, it's nothing but active evolution. Whenever you define and immediately executes, lazy evolution. Active evolution, sorry. Lazy evolution is like a function. If you got a function, right? If you are defining a user defined function, until you call it, it won't execute, right? If you're not calling, it is not getting executed, right? The same way in PySpark, we have got data flows. data flows. The data flows executes. On demand, we execute them. When required only, we'll execute. They are not executed automatically. They are not going to get executed, but on demand, we execute them. If required only, I'll execute. When required only, we'll call a function, right? So on demand, we call them. On demand, we execute them. That is what lazy evolution. Active evolution means immediately after defining, immediately executing, right? So PySpark main feature, lazy evolution. On demand, we execute them by providing an action. In-memory computation. In-memory computation means, so storage and processing everything within the memory level, right? In Hadoop, data won't be stored in the memory, right? Here, data storage happening and processing both happening within the memory, right? Fault tolerant. So if you see the PySpark, Spark has got a powerful fault tolerant model. If any slave goes down, then again, instead of re-executing, it can recompute and recreate the data, right? Yes. What the fault tolerance I'll be discussing separately. Persistence means the executed transformations can be reused. It means reusing already executed transformations will persist those. About this persistence, fault tolerance, so we'll have separate this. Immutability. Immutability means there won't be any change, there won't be any modifications or changes to the original data. Real life usage of PySpark. Real life usage of PySpark. In commercial sector, it is used, right? Real life usage means uses Apache Spark for real-time processing, right? Banks and financial fields, they're using Spark to retrieve customers' social media profiles and analyzing to gain useful insights and can help them to make the right decisions, right? So whatever that extracted information is used for credit risk assessment, targeted ads, and customer segmentation, right? So here a Spark plays a significant role in fraud detection and widely used in machine learning tasks, right? In machine ML and data science tasks. So in healthcare also we use Apache Spark is used in analyzing the patient's records along with the previous medical reports, right? And data to identify whether the patient is probable to face the health issues even after being discharged, right? So it is just going to for predictions and also for storing all the previous history of the particular patient, right? And in the entertainment industry also, like today, Spark is widely used as everyone we are just so if you see the entertainment industry is one of the largest sector which is growing towards online streaming. So everything it is moving towards online streaming, right? Means like OTT platforms, right? The popular online entertainment platform, right? Netflix, if we Netflix using Apache Spark for real-time processing. So to personalize the online movies or web series. Okay. So if you talk like in entertainment industry, right? So that Netflix, it can process approximately 450 billion events per day. Apache Spark can process approximately 450 billion events per day. And for trade and e-commerce, right? for e-commerce websites like Flipkart, Amazon, right? Apache Spark, they're using Apache Spark for advertising. So even if you see the other websites like Alibaba, it provides offers enhanced customer experience and optimizing the overall performance, right? And for tourism industry also, right? Widely this Apache Spark is used to provide advices to millions of travelers, right? For hundreds of tourism websites, right? Yes. And here, why we choose for Python rather than Scala means very less coding you see, very less coding we see in Python, and simple syntaxes given by Python. They look like normal English statements, Python syntaxes. Hybrid features of Python, multi-programming features. Multi-programming features means like Python has got, it has taken the advantages features from multiple programmings like procedural oriented, object oriented, scripting, and modular programming features. So just like procedural oriented like C language, it has got the features like object oriented like C++, Java, it has got features like scripts, we can write shell script, and for modular programming, modular 3. And interactive mode given by Python, we can easily interact with Python statement by statement. Just observe this. If I go to this command prompt, if I type Python, right, Python interpreter gets open. Any valid Python statements I can type and interact, right? X as 10, Y as 3. What is X I am asking? Gives the response. What is Y? It gives the response. What is X plus Y? It gives the response. Okay, in this way, any valid for X into 2 multiplication, X to the power of 2, power symbol, right? X into 2, 10 into 2, 20, 10 square, 100. So any valid Python statements, right? HELLO, X into 3, prints hello for 3 times, X into 5, hello for 5 times. So any valid statements you can type and you can interact, right? So here we see very simple syntaxes, very less coding, multi-programming features, interactive mode, we can interact. This feature which you cannot see in other program, many built-in libraries. So this many libraries provided by Python. If you see the speed, if you see the speed of Hadoop and Spark, right? So this especially is PySpark. Yahoo, there was many tests conducted, right? Yahoo has taken a table of 100 TB consisting of 1024 columns, right? The task sorting based on 16 columns, right? So what is the time taken for this processing this 100 TB data? Sorting based on 16 columns. Okay, time taken by the various databases, like Oracle has taken 3.5 days for this 100 TB data, right? For MySQL, it has taken 6 days, and Teradata 4.5 hours. 4.5 hours. So Teradata is a specialized database used for data warehouse purpose, can handle like TBs of data. It has not taken in days, it has taken in hours. Net is also a specialized database for data warehouse, has just taken 3 hours. And Hadoop has just taken 3.4 minutes. This has taken days and hours, right? But it has taken minutes. But Spark is, see, Hadoop has taken 3.4 minutes, but Spark is 100 times faster than Hadoop, I'm saying. Okay, so this is what. So the Spark is proven in the market. So processing point of view, it is faster than any other, right? And PySpark is mainly designed for batch applications, not for online applications, not for day-to-day operations. See, batch applications, online applications. There are two types of applications. Online applications means user is compulsory required for any online application for right? Compulsory user required to give the input. User should, if you want to make any transaction, user required. If you want to book anything on the online, user required, right? User gives the input. But here for batch application, yes, batch application means here user is no way required. User is no way required. User doesn't give any input here. So everything happens at the background. For example, most of the financial applications are batch. For example, generating credit card statement for millions of customers. It's a batch, not like no user is nowhere required. Phone bill generation, right? Phone bill statement, mobile statement, right? For millions of customers. Here user is nowhere required. And for iterative algorithms, since most of the machine learning algorithms are iterative in nature, and for interactive queries, right? For interactive queries and for streaming. Streaming, what do you mean by streaming or streaming data? Data which keeps on generating, which keeps on incrementing. Data which keeps on generating, data which keeps on incrementing, right? Such kind of data called like a streaming data, right? Streaming technologies available, and even like in Spark, like you can go for micro batching. Okay. It's mainly designed for batch application, user non-interactive applications, interactive algorithms, interactive queries. Okay. Features and advantages of PySpark. Very high speed processing we see. In-memory computation means memory level storage and processing. Distributed execution, the data will be distributed across multiple RAMs of multiple machines and are processed parallelly. Multi-language support, it's like Python, Scala, Java, and or language, multiple languages supports advanced analytics and for parallel processing. Okay, parallel processing, persistence means re-executing, no, that's reusing the already executed transformation, right? Powerful fault tolerance model. Okay, resilient distributed data sets. You need to know something about the resilient distributed data sets, RDD, right? In Spark, everything is an RDD, data object. Spark data objects are called as RTDs, Spark data objects. These RTDs again subdivided into partitions. Like for example, RTD1 divided into multiple partitions, P1, P2, P3. Spark data objects are called as RTDs. RTDs are subdivided into partitions. These partitions are distributed across multiple RAMs of multiple slave nodes. Here the advantage is bigger data sets can be loaded into RAMs. Okay. In Spark, everything is an RTD. In Spark, the programming style is data flow. Data flow means sequence collection of pipes. Sequence collection of, see here, Spark is a data flow language. Data flow is nothing but sequence collection of pipes. What do you mean by a pipe? Pipe means any data operation like loading the data, transforming the data, filtering the data, grouping data, merging data. So sequence collection of pipes. At each pipe, any of this operation, loading, transforming, filtering, grouping, or merging is going to happen. So you need to know something about this RTD computation, right? RTD computations. R1 is an RTD. R1 output is data flow, right? It's given as input to the next one, R2. R2 input is given as R2 output is given as the input. See data flow. What is data flow means? So from R2, R3. From R3, you will get like R4, R5, R6, R7, R8, R9. So each output will be the input to the next one. Observe this first flow. Observe this first flow, right? R1, R2, R3, R4, R7. Second flow. R1, R2, R3, R5, and R8. So, okay. Third flow, just R1, R2, R3, R6, and R9. So just now I was talking, right? Spark is a lazy evaluated. Spark is lazy evaluated. Either to execute any of this flow, you need to perform any kind of action. If you perform any action only, then the flow executes. If you perform any kind of action, see the first flow. First flow, if I say R7 is that last one, R7 dot action. Whenever I say R7, the last one, yes, the flow executes from the root to this R7. It executes from this R1 to R7. See first R1, see the flow. Whenever you say any action only, this flow executes R1, R2, R3, R4, R7, right? When R2, see, all these RTDs cannot be, all these RTDs cannot fit into the RAM. If each RTD size, bigger sizes, right? If 10 RTDs or 5 RTDs, all the RTDs cannot be loaded at a time into the RAM. When R1 is ready, computed, output collected by R2, R2 is ready and R2 is computed. R1 gets removed from the RAM. See, when R1, okay, observe carefully, when R2 is ready and computed, all R1 is going to get removed. See, R1 will be divided into multiple partitions. See, RTD divided into multiple partitions. RTD is a bigger data object. P1, P2, P3 into 4 partitions. First partition stored in system 1, system 2, system 3, system 4. Means in system 1, RAM 1, in RAM 2. But if you got 30 partitions, right? 30 partitions stored in 30 systems if available. And all these partitions are going to execute parallelly. All these partitions executed parallelly by 30 partitions executed parallelly by 30 systems. So I mean, multiple RTDs cannot be accommodated into the RAM. So if all the RTDs stored in the RAM for the incoming RTDs, for the upcoming RTDs, there won't be any space, right? So here, resilient distributed data sets, we say, whenever the next RTD is ready, the previous one gets removed from the RAM. Okay, just observe. When R3 is ready, R2 gets removed. When R4 is ready, R3 gets removed. When R7 is ready, R4 gets removed. When the total execution completed, when the output is collected, R7 also removed from the RAM. Now what is in the RAM? Nothing. So one by one RTDs, they will be loaded, computed, and they get removed one by one, right? Yes, if we just observe this second flow, same way, the second flow also is like this. R1, R2, R3, R5, R8. So when this is ready, when R2 also ready, computed, R1 gets removed from the RAM, R2. When R3 is ready, R2 gets removed. When R5 is ready, this gets removed. When R8 is ready, this also gets removed, right? The previous one gets removed. Once the total execution completed, output collected, this also get removed from the RAM. But here, every time you are executing from the starting, right? R1 to R3. R1 to R3. The first three steps are common. In all the flows. First three steps are common, but still you are re-executing from the beginning. So what you do? The RTDs whose output is used by many flows, you are going to persist it. You're going to persist it. Like we say RTD dot persist, R3 dot persist. Then it won't be removed from the RAM. First time, the first flow executes. First flow is R1, R2, R3, R4, R7. The first flow executes. In the first flow, if you observe this R1, R2, R3, R1, R3 will be persisted during this process. R3 will be persisted. So the flow is R1, R2, R3, R4, R7. When R2 ready, R1 removed. When R3 ready, R2 removed. When R4 ready, R3 won't be removed. It is persisted permanently. When R7 ready, this gets removed, right? Now R3 remains in the RAM. Now R3 is in the RAM. Okay. So now just I'll come back what we do in R1, R2, right? Yes, I'll just come back to that queries, right? In the second flow, now R3 available, right? I no need to start the flow from the starting directly. For the second flow, we need to start from R3, R5, R8 because R3 available in the RAM. Now R3 output I will collect and I'll go with R5 and R8, R3, R5, R8. Third flow also, R3 output I will take and I'll compute R6, R8. That is the flow, means number of steps are decreasing, right? Means I'm reusing already executed transformation. All right. So here query was asked. So R1 equal to using Spark context. If you're loading any file using any path, file path, using Spark context, if you load a text file, right, from any location or path, then RTD1 is created. RTD1, R1 dot filter, R1 dot filter those data based on a particular condition. R2 gets created. And on that R2, if you perform some kind of grouping or merging operations or map operations, R2 dot map, R2 output you are taking and you are mapping with something. R3 is created. On R3 also either some operation we are going to perform. R4 creates. Initially only R1 available. From R1, R2 got created. From R2, R3 got created. In this. Okay. So what is that R1, R2, R3 means? R1 is the file which you are loading. From that R1, if I filter only particular city data, particular product data, R2 got created. From that R2 again, I map something, merging or grouping or aggregating something, R3. From that R3, R4, right? Yes. So the one whose output is commonly used by multiple flows, the one whose output, this R3 output is used by 3 flows, then persist it. So from next second flow will be like this. R3, R5, R8. R3, R5, R8. Third flow will be like R3, R6, R9. So no need two steps decrease, right? For example, 50 steps are there. R1 to R50. R50 output used by R60, R70. First, this flow executed. R50 persisted. Persisted means making it available in the RAM. It won't be removed. Now, from the second flow, this one, if you want to execute, no need to execute from R1, from R50 to R70. That's it. Because R50 is available in the RAM. It won't be removed. The flow will be from R50 to R70. So these many 50 steps got decreased. The advantage of persistence. Okay. So what I'll be discussing as part of this course, right? Yes, you can just have a look what I'm going to discuss as part of this course. PySpark introduction. What is Apache Spark, PySpark, PySpark features, real-time use cases, PySpark repartition police, PySpark accumulator, right? It's PySpark RTD computation. Operations on RTD like RTD computation steps in RTD, persistence options, memory only, memory underscore SCR, disk only, disk underscore SCR only, right? PySpark core computation, fault tolerance, different ways of creating and word count example created Spark objects, increasing the number of partitions, aggregations, groupings and aggregations, right? Single grouping, single aggregation, single grouping, multiple aggregations, multi-grouping and multiple aggregations, and process of group by key, reduce functionality, and various actions and transformations. If you perform action only, then the data flow is going to get executed, right? So what are the actions like that? These are all the various actions and transformations, inbuilt transformations. On a RTD, if you perform transformation, the resultant what we get is also a RTD. But action, if you perform an RTD, the result what we get is a local object. Okay, various actions and transformations and PySpark SQL data frame. Yes, one second. I'll come back to your queries, right? Yes, PySpark SQL data frame introduction, making data structured, case classes, ways to extract the case class. Yes, different RTD. PySpark creating data frames, creating empty data frame. These data frames are very much important, right? Convert RTD to data frame to pandas, as PySpark struct field, row class, column class, select, collect with column renamed, variant filter, drop and drop, duplicates, order by and sort, group by, join, right? Yes, one second. Join operation, union or union by name, UDF, map, flat map, for each sample, fill null, pivot, partition by array type, map type, right? And we have got some many PySpark SQL functions, aggregate functions, window functions, date and timestamp functions, JSON functions, PySpark built-in functions, various built-in functions, right? When, expression, lit, concat, translate, overlay, to date underscore format, explode, collect underscore list, map keys, map values, struct, sum, average. Okay, and these are all the various array contains, array, create map, map keys, row number, dense rank, percent rank, JSON tuple, get JSON and object, and PySpark external sources, right? Working with the SQL statements, Spark and Hive integration, Spark and MySQL integration, working with CSV, JSON transformations, actions on data frames, narrow wide transformations, handling nulls, window functions, and deployment modes, local mode, cluster modes, right? PySpark applications, stages and tasks, driver and executor, right? Deploying Spark applications to cluster and tuning, performance tuning, integration with Kafka and PySpark MLlib, right? So this is what the entire syllabus we will be discussing of PySpark. So the prerequisites for this is like you need to have basic basic Linux knowledge, like just basic Linux knowledge means creating file, how to create a file, how to create a directory, renaming, right? Those things only, basic Linux commands. And if it doesn't have knowledge also, just I'll be providing the videos of that basic Linux commands. You can just go through and mm, basic SQL knowledge, normal basic SQL, right? And also like basic Hadoop. If it doesn't have knowledge on that, I'll be providing the videos of those, right? Like basic HDFS and scoop knowledge, you need to have basic knowledge. That basic knowledge, the videos I can provide, right? Yes. So okay, and basics of Python basic knowledge. Even I'll be just briefing you about the Python syntaxes, all the Python syntaxes before I'll go with the practical part. Fine. Okay. So a WhatsApp group is going to get created for the people for the interaction with me. Can have direct interaction, and clear notes will be provided. And for practicing that, I'm going to provide the software to you. It will be forwarded to your Google Drives. So once you get enrolled, once you get registered, right, you will be getting the notes, clear notes, the soft copy, and you will be added to the WhatsApp group. And every session video you will be getting. Every session is a video recorded. You will be getting the video of the every session. Okay. Any other queries, right? Anyone, right? And Spark, everything I'll be discussing, right? Not a problem. Everything the Spark knowledge I'll be providing. The videos will be for the 6 months. You can access the videos for the next 6 months. Later, if you want, you can extend it, or you can just purchase those, right? So it will be for, and total Spark knowledge I'll be providing now. Okay. Understood, right? So why we need to go for Spark, Apache Spark, and everything is in OTD here, and fine. Okay. So basic Linux and basic SQL and basic Python knowledge is enough, right? For this attending these things. Remaining everything I'll take care. So as I said, clear notes, the video, and that what all we'll be discussing. You see that we have got, I'm discussing huge. You can see the syllabus, everything step by step I'll discuss. And one second. So those tomorrow the link is going to change for the tomorrow session. So the timings of this batch will be right. Okay. So it's once again I'm making clear about the timings. Daily, like 3 to 5. The timing of this batch will be like 3 p.m. to 5 p.m. So from tomorrow onwards, it will be at 3 p.m. to 5 p.m. And now, okay, now we'll have a session at 3 p.m. right? You can have a break for 20 minutes now. Again, we'll continue the session at 3 p.m. today. So I'll be just giving the fundamentals of Python. Those who doesn't have knowledge on Python, just in today's session, just I'll be briefing you about the entire Python fundamentals, right? Yes, yes, Gaurav. Prabhat. So the demo up to now, okay, understood, right? What is PySpark? Why PySpark is designed for? What is the purpose for PySpark? And what is the data objects? Next, before I go with the practical part of this, right? First, I want to just give you knowledge on this Python, right? So today, like 3 to 4:30 today, right? You can just have a break for 20 minutes now. Later, I can 3 to 4:30. I'll be just briefing you about Python fundamentals before I go with actual PySpark, right? Okay. And tomorrow the link will be changing. If anybody, those who are interested, those who want to enroll, right? You need to just uh, there'll be a paid link. Not the, tomorrow the link will be changing. You will get a new link to your mail IDs. So that the details, everything you can see in the chart panel, right? Posted by this online team. Totally, you can see that a big message given by the online team about the payment process procedure, the course content. It's a 10 weekends batch. The duration is it's 10 weekends. 10 weekends means nearly 2 to 2.5 months. The yes, the fees is 8,000, that which includes class and videos, soft copy of the materials. If we can, even you can make a note of that online team, those mobile numbers for any details related and this payments processing details, right? Yes. Any more queries from your side, anyone? So we are starting, yes, from today. Okay. So from tomorrow, actually, that's classes will be started. Tomorrow is just fundamental to PySpark, and after that, I am giving fundamentals of Python, right, at 3 p.m. If you doesn't have knowledge, if anyone who doesn't have knowledge on Python, right, at 3 p.m. today, 3 to 4:30, 1.5 hour, I'll be just briefing you about the. You can follow the same link. You can just follow the same link, right? Okay, you can just talk to the online team. Yes, Avinash, right? Uh, you can talk with the online team. You can take the detail, and you can, and don't forget if you are making payment, don't forget to send the screenshot of the payment to Durgasoft online training. You can see that they have given a mail ID, Durgasoft online training at the rate gmail.com. You are supposed to send the screenshot to that mail ID. Then they will forward you the link for the tomorrow's class. Tomorrow's class will be from 3 to 5. And every week the class will be from 3 to 5. And today I'll be giving the fundamentals of this. Python fundamentals will be discussing. And tomorrow we'll go with the actual part of that. Any more queries, right? Anyone? So just get enrolled and get the notes, software, videos, okay, and continue with the sessions, right? Fine. So for at 3 o'clock, you can follow the same link what you are using now. So break will be for 20 minutes. So at 3 p.m. you can follow the same link, right? Okay. Fine. I'll be providing you the software once you got enrolled, and WhatsApp group, everything you'll be added, right? Yes. Fine. Okay. So I'm stopping here. We'll meet you after the break. Any more queries before I end? Yes. Okay. Fine. Thank you all for your time. Thank you. Meet you at 3 p.m. on this basics of PySpark. It's Python, sorry. Basics of Python.